You know, they changed the time last Saturday, so it's actually 11:30. Hi, I'm Vera.
And I'm Christian, and we're back. And in this episode, I want to tell you about some interesting engine facts on the TDV6 Diesel, which I discovered during my repair effort to fix Fabian's Land Rover Discovery 3. The oil seal rides on this spot.
Oh, that's like stupid. Hope you enjoy the video.
So here we are again, and we're gonna have to get the engine block ready to have the crankshaft ground. I hope everybody watched our last video from the line boring job. If not, you should definitely go do that and follow this series. This is almost live, so this is not filmed and then posted and it's all history and the car is already running. No.
It's all real time.
What we're doing now will be posted next Sunday, and we don't know the outcome. It might get really embarrassing at the end because everything we did went wrong and the engine stalls again, and then we're gonna make a video about that, and it's gonna have a lot of oh my gods in it.
Oh yes.
Now, what does the engine block have to do with grinding the crankshaft? And there is my plan to install the undersized main bearing shells and get the block completely tightened and torqued, and then take it over together with the crankshaft to my machine shop specialist, which I found, and he's gonna grind the crankshaft to fit the mains as good as possible.
Oh my God.
How did you survive with no oh my God so far? We got a shipment out of the UK. Luckily that still worked. Took a bit more than a week, I think. So what I ordered in the UK is a set of King main bearings, which are a 1/4 millimeter undersized. The OD is original. The ID is supposed to be a 1/4 millimeter in diameter undersized. And then what I have in addition is a set of original connecting rod bearings. They are original size, as if the crankshaft would not have to get ground. And then I got a set of undersized pin bearings for the crankshaft. Why? Because I want my machine shop guy to only regrind those connecting rod bearings which are damaged. And the others I gonna most likely install the original bearings. Let's go check out the crankshaft.
Here and here, which was not heated up and bent.
Let's go. Maybe I'm getting an oh my God out of it. So
No.
here's the crankshaft. We're only gonna get those pin bearings ground, or those pins ground, which are damaged. That's my plan. But maybe my machine shop guy is gonna say he wants to regrind all of them, whatever he wants. So that's the plan.
That's
And
Fabian.
here I got a setup where I cleaned the crankshaft so that I'm giving him a really clean and prepped crankshaft. I basically used sandpaper and let the machine spin, and I cleaned up the mains as good as I could with sandpaper so that he can take already measurements and he doesn't have all the gouged up material on there.
It's actually quite interesting seeing it here.
Let's ask a couple of
Oh,
questions.
please don't.
Okay, you should have learned, what are these holes?
Oh, they are from the balancing process.
From the balancing process.
Yeah, you know,
and
they're drilled.
what are these pieces called?
Pork chops.
Very well. They called pork chops, okay? And the balancing process drills into the pork chops. Okay, what are these called?
Main bearings, but I don't know which. I see more than 4.
Well, then count them. How can you see
1, 2,
more?
3, 4, 5, 6.
No,
7,
now
8,
you're
9.
counting the main bearings and the
I don't know.
pin bearings.
Oh.
That's where the connecting rods go. So the main bearings run on center,
Oh.
and the pin bearings operate the connecting rods. They are out of center.
You know, the ploil.
Yes,
The stuff that goes into the cylinder.
Yes, the
In
stuff
pork.
which goes into the cylinder. Correct. So everybody got that now? So what is connected to this flat here?
To that flat?
Yes, to that diameter. What mates with this diameter?
I don't know. The flywheel? The oil pump.
Yes, the oil pump. So what are these lines from here?
Oh man. Yeah.
There's the seal. And now back here on this end. What rides on this spot here?
I don't know.
Well, the oil seal rides on this spot.
Oh, that's like stupid.
Now, what are these holes?
Well, those are the most important ones. That's where the oil gets to.
Exactly, those are the oil holes.
Yeah.
And what do they do?
They supply oil to the bearings.
From where to where?
From the main bearing to the pin bearing.
Now let's go back to our actual job. Okay, here. Let me open this up first. So
Open
that
it
I can,
up?
Yeah, let me open this up first so that I can use these pieces.
He's going to be quiet and I'll hold the camera steady, and we can do that in a time lapse.
Yeah, we do it in a time lapse. Then I look even stupider. Yeah. Oh, did you see my new ratchet?
Now the time lapse is ruined. I like to see you sweating. Now he's using... Oh my God.
Man, those bolts were hard to get. I had to buy them in the US. I ordered them and have them sent to Rob's house. And then Rob's gonna send them over.
Because everybody know who Rob is. And we don't have the new screws.
The new screws will be used only one time when we install the crankshaft and everything is finished. Until then, the old screws will do. Okay? Whenever you have what's called a stretch bolt, these bolts stretch under torque. Okay, so you tighten them to a set torque like every other bolt, but then you give them an extra 180-degree turn, and during that turn, that material actually stretches apart, and the bolt works like a spring with a very, very high preload. And this way, if there are heat expansions or contractions in the engine block, the high torque and the springy action of that tension bolt will make sure that it will never lose contact. Okay?
Usually we fix everything with Loctite.
No, there is no Loctite on a stretch bolt. Okay? What is very important here, but we come to that when we tighten them, is the tightening order and also the type of lubrication used.
Oh my God. I wonder how we managed to work for 30 years on our cars without that kind of lubrication.
Yeah, that's what she said. Here are the mains which we bought out last time, and we didn't have any good footage how clean this is, okay? This is the surface where we fit now the main bearings, and the surface roughness matters, okay? So this must be relatively smooth. If it is not smooth enough or smooth enough as the original ones, then the bearing contact will not have the proper heat transfer out of the bearing into the bearing mount, out of the bearing shell into the bearing mount. How do I know that? By reading in the internet. And this may not be smooth enough, but I can't get it any smoother because otherwise I would blow the dimension.
But what do you mean it may not be smooth enough?
Well, that maybe Fabian is watching that video thinking, oh my God.
Yeah, but can it damage the engine to a stop again?
Anything can damage this engine.
Oh my God.
Okay, so.
Man, I hope that was an old one.
That was an old one. Okay, so here you see the bearing smoothness between my line board one and polished one and the original. So the original is better, no doubt.
That's original?
That's original, and this is line board from me.
It's rougher.
Okay, it's rougher. And the surface roughness of this is specified by the bearing manufacturer, and most likely we're not meeting this specification.
Oh my God.
But life is tough. The instruction manuals from Kings suck. But the instruction manuals from Mahler,
what's that? Oh, another
that's a
bearing.
German manufacturer. They are good, okay? They have excellent instruction manuals. So I'm gonna use now the Mahler instructions as a guideline for the King bearings, okay? So that alone may screw up the engine.
Oh my God.
What they say here is basically the finish of main bores, okay? There's the value, is supposed to be 60 to 90 micro inches RA. RA is surface roughness, so Rauigkeit, yeah, surface roughness.
But how do you measure a
You
number
would
like
need
that?
to have a surface roughness gauge.
Yeah.
And I have one like this. I show it to you. It's really easy.
We have one?
Yeah, I show it to you. There you go. Oh yeah, this is really good. This will do. So surface roughness is gauged, and we can move on to the next step. What I wanted to do is, while we installing those bearings, is address some of those questions we got from some viewers.
Yes.
From the line boring videos. Thank you guys for those questions, because they make me research certain problems in the internet, and then I realize, oh shit, I should have thought of that. First of all, a question we got a lot, and I just read one of those. The one I got here is from Robert. Great work and good entertainment. Is it possible for you or a machine shop to notch the block or caps and split the bearing shells like it was done in the older engines to prevent the bearing shells from rotating in the block and maybe stop future problems? JJ worded it. Would like to hear your opinion as to why the bearings do not have location tanks on them. JJ called them location tanks and Robert called them notches. I researched this in the internet, and what most people think is that the reason these bearings spin inside the block, okay, the spinning is basically when these bearing shells get loose and then that's the old one, and then they scoop around like this. They're not supposed to, okay? The crankshaft is supposed to spin inside these bearings, and these bearings stay stationary. So that's the problem of having spinning bearing shells. And this spinning will seize up these surfaces, and that's why we needed the line boring in the last video. There were questions where this still was not clear. People have been saying, well, bearings are supposed to spin, aren't they? Why is that such a problem? So these bearing shells stay stationary, and when they spin, they gouge up the block like they did, and this is why we did the line boring.
Yeah.
And now you have many bearings out there which have notches. They punctured in here, and then there is a groove here, and this is where the bearing sits inside, like this, nicely located. And because this notch is sticking over and the cap goes on, the bearing from looks can't spin. But here's the point. The notches are only there for locating the bearings axially. They're there so that when you put the bearing in, that you don't put it accidentally in like this or accidentally in like this. They make sure the bearing goes nicely into the center. Do bearings spin if they have notches? And the answer is yes, they spin the same way. If it comes to a dramatic engine failure, the bearings will get put under so much load from seizing up to the crankshaft that they will spin even with these notches. The notches will just shear off.
I mean,
and
look
the
at
damage will be the same.
tiny bearing and that huge crankshaft.
Notches are only there for an axial location of the bearing shell and not to prevent them from spinning. So you can install bearings with notches by grinding in the notches yourself, but then you grinding in a permanent location, maybe with a die grinder by hand, and if you mess that up, your bearing will not sit centered. Versus when you do this by hand, you can set your bearing in nicely, centered, and then put your cover on top and everything will be good.
Okay.
There are different crankshaft designs. And the crankshaft we have here on a Land Rover Discovery 3 and Discovery 4 is what's called a forged, fillet, rolled, induction hardened crankshaft.
Oh my God.
Everybody know what forged means, okay?
Of course.
Take a look at the crankshaft. See, this is called the parting line, okay? In a casting process, you have a parting line because you have a lower set of the casting and a top set of the casting. You put the two together, you put your casting material in, which could be aluminum or steel or plastics, and when it's all cooled down, you open up your casting, and that bead around it, it's called the parting line, okay? And on a forging, you also have a parting line, but the parting line is much, much wider. You can see that's like more than 1/2 inch wide. That's how you can see that this is a forged crankshaft. And a forged crankshaft from the material is a advanced crankshaft compared to a cast crankshaft. How do you forge a crankshaft like this? You have like a bottom of the forge, which is usually called the die, and then you have a top of the forge, which is usually called the punch, at least in my world. And basically you take a red glowing billet, which is like a piece of steel, which has the correct size, diameter and weight and length, and you put it over your die, and then you ram down the punch with a huge force, and it will create this crankshaft raw shape, donk. And then the material will be pressed out wherever the die and the punch stops. That's where you have a material bead left over. And that will later on, in some cases, get sheared off, cut off, or machined off. Now, why did we come in here? I wanted to show something.
Yeah, I forgot.
Forged, fillet, rolled, induction hardened crankshaft. And we wanted to explain what that means. So we explained now forged. So what is fillet rolled?
I have no idea.
Fillet roll means you have, wherever you have a bearing surface, here get me a close-up. Wherever you have a bearing surface, you have this little radius cut here into the side, okay?
Oh.
The machinists call this a fillet.
Really?
Okay? And a fillet is a stress relief cut. What we saw inside was a shape like this.
Don't we have a paper without oil spots on it?
This is a really important paper where people would pay millions for, okay?
Okay.
So, this is what we saw inside, okay? So this is our crankshaft here.
Really?
Yeah. Okay, this is where the pork chop was. And this is then later on where our bearing is installed, right here, yeah? And then there is the connecting rod installed. Yeah, so this is the connecting rod. And this is the bearing. And fillet rolled means that, first of all, the crankshaft has a fillet, so it has this radii. Instead of, imagine it would be looking like this. This would be an alternative. Or it could be looking like this. Okay? What is the problem with this design? It develops a crack right here due to stress. And it will fracture right out of this corner. So that's why people put, wherever you are in the machine tool industry or in any kind of structure where you have a load on, you put a radius into a corner. And that distributes the load over the full area, and it causes the material in this area to be stronger. But what would be the problem with this design? If I now add my bearing onto here, like I did over here, there would be a risk of this bearing scooping over and getting onto this radius here, for example, during assembly. So it would not have the necessary clearance. Okay, this would be here, looking like this. This is not a good situation. That's why they want there some clearance to make sure that this bearing can here ride later on freely, and under no circumstances it's rolling up on, onto this radius. That's why they put this radius in here called a fillet. And a fillet has the same stress relieving effect as this radius, okay? So the stress is nicely distributed here into this entire area and not going out of one corner, causing a crack. But in order to make this even stronger, they use what's called a fillet rolling process. So during the manufacturing process, they will actually, hang on, I gotta get me a pen for my scientific explanation here.
I don't see what you're drawing.
Oh, you don't see what I'm drawing?
No, I don't see
it. Okay, so this is where the center line is. What? From the pin bearing, okay? And this is where the fillet is. This is where our pork chop is, okay? And this is where our main bearing is. I can only hope that everybody else sees it. What is fillet rolling?
No
That's
idea.
A process used in crankshaft manufacturing now for maybe 20 years, I'm not quite sure. They actually use a roller wheel. They use a roller wheel which is oriented like this. and like this. This is the axis of rotation. And now they roll this wheel around the fillet. And they put force onto this wheel in this direction. A high force. This is a hardened wheel with a diameter of maybe 3 millimeter here in this area. So this is like maybe 3 millimeter here. And they put a force on here. This force is approximately 7.5 to 9.5 kilonewton on a Land Rover crankshaft out of this manufacturing year. And they do that on both sides at the same time. So the fillet tool comes in. It looks like this. I can maybe overlap there a video from a manufacturer who builds fillet rolling machines. So they bring this tool in and then they roll it. Actually, they roll the crankshaft, but they hold the tool stationary with a large force. And what that does, it condenses the material here in this area, sort of like a cold forging process. And that further increases the stress relief ability of that area. Now, we clarified forging, fillet rolling, and now we have to clarify induction hardening. And that's actually what I wanted to get to. Because I said we're going to have to regrind the crankshaft. And we have many comments now, and their concern is, well, what will happen with the crankshaft if I grind it? Will it lose its hardening? It would be terrible if it loses its hardening. Fabian would lose all kinds of sleep. Okay. The hardening depth of the TDV6 crankshaft in the 2.7 liter diesel version at the mains and at the pins has a 1 millimeter hardening depth guaranteed to 50 HRC.
To what?
50 HRC. That's the unit for measuring hardness. The induction hardening process on this crankshaft only takes place at the relevant areas. The reason is very simple. You don't want to induction harden the entire crankshaft. You have to see that like a sword back in the old days. If you would have a sword which is entirely hardened and you would bend it, it would break.
Oh, Robin only hardens.
Yes, he hardens only the cutting edge.
The cutting edge, exactly.
Okay? So if you would harden a crankshaft, it would get all brittle at HRC 50 and it would break. That's why an induction hardening process only hardens those areas which are under high demand. And these are the mains and the pins. And the way the induction hardening process works is that the manufacturer brings in electrodes, they close over the mains or over the pins, and they introduce a current through an induction process. And while they rotate the crank, they get this to all glowing. This will actually harden it. So they got this dialed in that the amount of heat they put in over the amount of time is exactly causing this surface to harden. Induction hardened in this case means 1 millimeter of hardness depth. And I said our bearings are undersized by 1/4 millimeter, so 0.25 millimeters, which means if everything runs on center, my machinist is going to grind off 0.125 millimeter out of theoretically 1 millimeter hardness depth. Now that took a lot of research.
Yeah, and oh my God, that's not going to work.
This is my fillet again. This is the bearing surface. We said this here is fillet rolled, this area, to strengthen it. This area is induction hardened, and this induction hardness is actually introduced like this. Okay? They can't introduce it, for example, like this. If they would do this, they would get stress fractures here again. So they only induction harden this surface here, in this area. And this is the depth. This is basically the 1 millimeter depth. And you can see how it rolls out on the side. And then they specify this dimension. So they specify a minimum width where the induction hardness needs to take place. So these guys know what they're doing, that's for sure. Another question we got, I wanted to address in our little bearing installation job, we haven't even started yet, is the shop cost to have such a block remachined. We got at least 2 or 3 people asking, well, why don't you just take that over to a shop and have it remachined by them? Or why don't you just get a new block? Or how much does a shop charge to get the line boring done? And I want to address that question because it's a really good question. It's a budget question, okay? And we are repairing this engine block on a budget. We want to do the entire disaster below 2,000 euros for Fabian on spare parts and repair cost. Let's address the question, how much would a shop charge to do the line boring? And the answer is they charge about 8 hours of machinist rate.
8 hours?
8 hours of machinist rate. So if they have a rate from 80 euros, it's 8 times 8, it's 640 euros. And here's the big but. That does not include their inspection, their cleaning, and their extra warranty. If you want to get them to do this job and later on it doesn't work out, the dimensions are not where they need to be, you're kind of done. In other words, shops do not want to do a line boring operation only. They want to do the full job and they want to charge a lot more. They want to charge the cleaning, the inspection, they want to charge the assembly of the block so that the bearings are back in. They want to do the line boring and later on they want to install the final bearings. They want to do the crankshaft grinding. This is what they're doing. And then you're being charged 5,000 euros for the entire job. But then you have a professionally rebuilt engine. So they're doing a good job. I asked 3 well-known local machine shops around here who are professionalized in engine rebuilding, and all of them declined to do the boring operation only. But they all gave me a price what the boring would be if I buy it in a bigger package. 8 hours. Okay? The next line is, why did we not just simply put in a new engine block from the scrapyard?
Well, because it comes from a scrapyard.
Yeah, that might be a problem for Vera, but it wouldn't really be a problem for me. It would be possible to get an engine block from a scrapyard and inspect it and make sure it's correct and install it. That's not a problem. But remember the budget. An engine block functioning undamaged from a TDV6 is at least 1,500 euros in Germany. And then you don't know what you get. You may get an engine block which has worn out cylinder bores and you buy it at the... That wasn't good.
Oh my God.
I'm gonna have to dress up this corner. See right there?
Yeah.
That's why it's Fabian's engine block.
Oh,
so you would not know what you're gonna get. And you would have to inspect it then once you're at home and you find out I need 6 new pistons because I don't have the mating pistons.
Pistons is
the
what it's
is
called.
That stuff what goes up and down in the cylinder block, okay? You may find out, oh, I gotta do some additional honing on the line bore or whatever. So you're gonna end up installing a lot more components versus on Fabian's engine, the combustion areas, so the pistons, the piston rings and the cylinder heads are perfect. We don't need to do anything. We don't even need to re-hone anything. We don't need to replace the piston rings, nothing. Everything is still good. We're not rebuilding this engine to last 250,000 kilometers.
We're not?
No, we're not. Because
Oh,
if
man.
he wants to do that, he would have like 6 to 7 grand to spend. Then I could tell him, yeah, now everything is new. But we're not going to do that. We're going to get him his engine back together so the car lasts maybe 300,000 kilometers as it would have without this severe damage.
Oh, 300,000 is good enough.
Rebuilding this engine so it's as new condition would only extend the engine life by maybe 100 or 120,000 kilometers, maybe 150,000. And for that difference, he would have to spend 3 or 4 grand more. So it's a budget decision. It makes no sense. His car, if it lasts another 150,000, that's probably 6 years for him. He's going to be done with it by then. And that's why we decided to rebore this engine, because we got it rebored at 0 cost. I did everything myself, instead of having a block and new pistons and other things you need when you change the block.
Like a crankshaft.
No, not necessarily. Yeah.
Okay.
So
But it comes from the scrapyard. So why did it end up on the scrapyard?
that's exactly the
That's
question. Yeah? Does that make sense?
Yeah.
Are you bored?
No.
I have to open the new bearings.
Oh, I don't want to do that.
Very simple to distinguish between the upper and lower bearings, okay? The upper bearings, the ones which mount in the block, are the ones with the oil holes, okay? So it fits right in here. And these bearings are now...
They don't fit.
Yeah, they better fit. See how they go in here and how nicely they snap in place?
Well, I didn't see
Okay,
that.
and now
Wow.
they... When I get them now even here on one side, if I get them even on one side here, you feel actually a lip here. Touch this on this side.
Yeah.
You feel this
good.
lip?
Yeah.
This lip is called the bearing crush.
Ooh, only 10% battery remaining.
If my bores will be out of condition, like out of round or out of diameter, even so I did them as good as I could, we may have too little or too much bearing crush. And then the bearing is not held in place by compressing the two shells together.
And then what?
And this could cause the bearing later on to spin. And we have the same damage again.
But
These
that
are the
one
upper
has
ones.
a...
See, there's the
has a
sides.
rim.
Yeah, this has the thrust bearing. Okay.
Thrust
The thrust bearing. So you have to guide the crankshaft here radially. But at one bearing, you also got to guide it axially. You got to make sure it's not slopping back and forth.
Oh, okay.
And this is what this face is doing.
Oh, okay.
That's then the thrust bearing face. Okay.
And do you
this
know
is
where to
also
put it?
flushed by oil, and it goes into the last main. The last main has special machining here on the side. So that what takes up the thrust bearing. And then this thrust bearing, once it's installed, get captured between the pork chop and another shoulder to make sure the crankshaft isn't going side to side. Every engine head knows that. And now, did you notice?
That's where the oil comes.
That the oil holes in the new bearings are much bigger than in the old bearings. Look, this is the old bearing.
It doesn't look old.
This is the old bearing, the only one which survived. All others got destroyed. But see how small this oil hole is compared to this oil hole.
Why did they do that?
I hope they know what they're doing, because this could be a huge problem. It changes the oil pressure and oil distribution. It also reduces the bearing surface in this area significantly. So it could cause the oil film which builds up to interrupt here on the side, because there's just not as much room left.
And you're sure you didn't order the wrong bearings?
I ordered the King bearings, which everybody uses. So I hope these guys know what they're doing, because Ford designed them like this, and King put a much larger hole into them.
Oh, now I'm stressed. I think my battery is empty now. No?
See that I'm sticking this in?
Yes, but I have to look through that small screen, you know.
Okay, so this
why.
is the crush we have, and now we want to see if this crush tightens up when I give it here more torque. And I'm even going to give it a little bit torque over here, just a little, because this bearing is of course bending a bit. And no tightening. No tightening, so I think we have a lot of crush. Yeah, now it tightens up. This is it. All we wanted to do now is make sure that these bearings are not too small. We want them to get crushed into the bore. And I could not find any good measurements on how much bearing crush is and how you measure it. So
Why don't we do it in the right order? Why did you start with the middle one when you're supposed to start with the first?
The lower main thrust bearing has only one shoulder. That's normal. And I don't know what orientation, but I can clearly see a witness mark here. So that's where this side of the thrust bearing goes. So and this bearing goes in here, facing with the arrows forward. This is the one I dropped. Fixed. You enjoyed that?
No, not really.
Make sure the surface is clean.
And you put in the correct bearings.
Yeah, I put in the correct bearings, and I even put them in the
But you opened only one
in
box.
the correct orientation. Yeah, because I bought so many just to confuse you.
Yeah, I'm confused now.
Perfect, this fits. So now we can do the entire torquing in the correct order.
So he's fixing his numbers.
I almost got this confused.
Oh my God.
And we don't want to screw this up because we want to take accurate measurements.
Yes, and I don't want to do it again.
So one is this one.
Now he's on the other side of the engine. Oh my God.
$17, $21. Now I gotta do my 60 on all of these.
Yeah.
Okay. So now we get 145.
Are you sure it's 145?
Yes. There you go. 90 degrees. Whew.
I got dirty hands, I helped.
33 Newton meters. So it's 100 below the 30. Oh. And the inside. Oh. Oh, this is not good. But that's actually an original bearing.
Yeah.
So I'm complaining right now over an original bearing. Let's see how the one is which I bought. It's tighter, see? That's it for this video.
Hope
Yeah.
you enjoy it.
And you guys remember, this is all basically live, okay? If it doesn't work, there will be a funny video how it doesn't work. So, and we'll see you
Next Sunday.
Thanks for watching. Can you repeat this now or you don't?
Yes. Here is the oil seal. That's where the oil pump sits. That is a main bearing.
Yes.
A connecting.
That's a pin bearing?
A pin bearing.
What is connected to the pin bearing?
The pleuel.
And what is connected to the pleuel?
The
Stuff which goes into the cylinder block?
yes.
That's good enough. That's good enough. Then continue.
Also pin bearing, main bearing, pin bearing, pin bearing, main bearing, pin bearing, pin bearing, main bearing, a seal, and then the crankshaft sensor, positioning sensor,
Perfect.
and the isn't it another seal or is that the sensor
No,
that
same.
broke?
No, don't disturb now everybody. What is the last thing? The
Flywheel.
exactly. Very well done.